Today's lesson will be on graphs of equations. This is section 1.2 in your textbook. The essential question for this section is, how do you sketch graphs of equations and what tools are available to help you in this process? We are going to begin this lesson with an explanation of what an equation in two variables is. This is an equation which basically has two variables, typically x and y. For example, we could have y equals 10x minus 7. We have two variables, x and y, and this is in an equation. Now, what are solutions for this particular equation? So now we might ask ourselves whether the point 2, 13 is a solution for this graph. So if I want to see whether 2, 13 is a solution, I simply plug in 2 for x and 13 for y in my equation. And if I simplify this, I get 13 equals 20 minus 7, or 13 equals 13, which is a true statement. So therefore, 2, 13 is a solution for this equation. So now let's see if the point minus 1, minus 3 is a solution for this equation. So if I plug in minus 3 for y and minus 1 for x and into the original equation, and let's see what I get for a result. So if I simplify and solve, I end up with minus 3 equals minus 7. Well, that's obviously not true. Minus 3 does not equal minus 17. So therefore, minus 1 minus 3 is not a solution for this equation. So let's say I want to find all the solutions for this equation, y equals 10x minus 7. I've got one solution, which is 2, 13. Well, the easiest way to find all the solutions is to graph this on the xy coordinate plane. And the easiest method for graphing is simply to do the point plotting method. Now, step 1 of the point plotting method of graphing is, when possible, isolate one of the variables. In other words, get it so that it says either x equals or y equals, okay? Step 2 is to construct a table of values showing several solution points. Now, when you're constructing this table of values, pick easy values. For example, if your equation says y equals 10x minus 7, like our original equation was, pick easy values for x. The easiest values for x are like 0, 1, 2. So pick some easy values and plug them in and get your corresponding values for y. Step 3 now involves taking these points from your table and plotting them in a rectangular coordinate system. And obviously, the more points you have, the more accurate your graph is going to be. Now, once you've plotted these points, step 4 simply involves connecting the points with a smooth curve or line. So if we go to our original equation of y equals 10x minus 7 and create a table for x and y and pick values for x of 0, 1, and 2, and plug them into our equation, we can get corresponding values for y. And you can see that we'll get minus 7, 3, and 13 for the corresponding values for y. So if we go ahead and plot these points on an xy coordinate plane, our 3 points might look like this. And if we connect the points with a smooth curve or line, our graph for y equals 10x minus 7 would look something like this red line here. Now, as our equations get more complicated, some other tools could prove to be useful in graphing equations. Now, the first of these would involve finding intercepts. Well, what do we mean by intercepts? Intercepts are merely where the equation crosses either the x or the y axis. So the x-intercept would be where it crosses the x-axis. The y-intercept would be where it crosses the y-axis. So the first step to find the x-intercepts, or where the equation crosses the x-axis, we let y equal 0, and solve the equation for x. And whatever our values are for x, those would be the x-intercepts. In step 2, to find the y-intercepts, or where it crosses the y-axis, we let x equal 0 and solve the equation for y in order to get those values where the equation crosses the y-axis. The next tool that we might be able to use is symmetry. Graphs of equations can have symmetry with respect to either of the coordinate axes or with respect to the origin. So here are your three examples of symmetry. On the left, we have x-axis symmetry, whereas if you folded the graph along the x-axis, what's above the x-axis would perfectly match up with what's below the x-axis. The middle one is y-axis symmetry. Again, if you would fold that along the y-axis, what appears to the right of the y-axis would match up perfectly with what's to the left of the y-axis. And then lastly, we have symmetry with respect to the origin, and that is if you drew a line through the origin, you would have points equally distant from the origin in the upper right quadrant as well as the lower left quadrant. Now there are different ways to test whether an equation has symmetry. First of all, there's the graphical tests for symmetry. So a graph is symmetric with respect to the x-axis if, whenever the point x comma y is on the graph, x comma minus y is also on the graph. Next, a graph is symmetric with respect to the y-axis if, whenever the point x comma y is on the graph, minus x comma y is also on the graph. And lastly, a graph is symmetric with respect to the origin if, whenever xy is on the graph, minus x minus y is also on the graph. Now, similarly, there are algebraic tests for symmetry other than looking at the graph. The first of these algebraic tests says that the graph of an equation is symmetric with respect to the x-axis when replacing y with minus y in the equation yields an equivalent equation. Now the second case is the graph of an equation is symmetric with respect to the y-axis when replacing x with minus x yields an equivalent equation. Now what I mean by an equivalent equation is the equation doesn't change from what it was originally, okay? So if I make that substitution and I still have exactly the same equation as I had before, that's what I mean by an equivalent equation. And the last case is the graph of an equation is symmetric with respect to the origin when replacing x with minus x and y with minus y yields an equivalent equation. So in this case, we replace both x and y with the negatives and the equation stays the same. The last thing we're going to talk about in today's lesson is circles. And I think you all know what a circle is, okay? Now, graphing a circle, however, is something that we need to address in terms of what the equation would look like and how we graph it. So what does the standard form of the equation of a circle look like? So the standard form is going to look like this. Parentheses x minus h quantity squared plus y minus k quantity squared is equal to r squared. Well, what do all these letters mean? Now, h comma k is simply the coordinates of the center of the circle. Now, notice, in the standard form, we've got x minus h and y minus k. Well, the center of the circle does not have those minuses in it. It is simply h comma k. So r is simply the radius of the circle. So as I said, the center is h comma k and the radius is r. Let's look at an example. So what we want to do is write the equation of a circle whose center is at minus 1 comma 2 and whose radius is 4. Well, if the radius is 4, we know what r is. If the center is at minus 1, 2, we know what h and k are. So it should be fairly obvious what the equation is going to be. Now the equation would look something like this. Now notice the first term is x plus 1. Why is it x plus 1? Because the standard form is x minus h. H in this case is minus 1, so it's x minus a minus 1, or x plus 1 quantity squared, plus y minus 2, because 2 is k, quantity squared, is equal to 4 squared. Now obviously the 4 squared we can say is equal to 16, which gives us our final equation. So let's say we have an example where we know the center of the circle is at minus 3, minus 5, and a point on the circle is 1, minus 2. Well, how would we get the equation? Well, basically the point 1, comma, minus 2 gives us x and y. The center, minus 3, minus 5, gives us h and k, so therefore we should be able to solve for r. So in order to solve for r, we would have r is equal to the square root of 1 minus a minus 3 quantity squared plus minus 2 minus a minus 5 quantity squared. So if we say 1 plus 3, that's 4, quantity squared, which is 16. If we say minus 2 plus 5, which is plus 3, quantity squared, which is 9. So I've got the square root of 16 plus 9, which is the square root of 25, which is simply equal to... So now we know h and k, because we know the center of the circle is minus 3, comma, minus 5. So h is minus 3, k is minus 5. We also know that r is equal to 5. So this becomes a fairly trivial operation to figure out what the equation is going to look like. So the equation of our circle would simply be the quantity x plus 3 quantity squared plus the quantity y plus 5 quantity squared is equal to 25. Now I would like you to write the equation of a circle whose center is at the origin and whose radius is 4. Post your answer in the drop box.